Yes, good afternoon, everyone. Hello, dear authors and invited guests. Welcome to Technical Session 5C. It is my great pleasure to welcome to the 6th International Conference on ICT for Sustainable Development through Zoom on behalf of ICT4SD 2021 and Global Knowledge Research Foundation. We are thankful to everyone present in the meeting to join along with us digitally for the conference in these unpredictable times of COVID-19 and making this conference more productive. We hope you will enjoy the knowledgeable and interactive sessions in this session. I would also like to introduce our session chair. Just a minute. Dr. Paras Kothari is presently working as a professor at Madhav University, Abu Road. He is having a long academic pathway of 23 years working with various capacity in prominent institutions of Gujarat and Rajasthan. He received his PhD from Faculty of Management Studies, Mohanlal Sukhadia University, Udaipur. His primary research interests are in the areas of planning, controlling, and development of an IT project. He has worked on many projects regarding Windows applications and web applications. His work has been accepted at various academic and conferences and seminars. He has also pursued MCA and MBA degree from IGNOU. Thank you for your presence, sir. Thank you. So, there's also a note for the presenters. You will be given 8 minutes for your presentation and 2 minutes for the question and answers. So please kindly stick on to the time frame as we have parallel sessions going on so that it doesn't take too long to complete the session. So we can begin with the first participant, that is Preet. Are you here, Preet?
Yes, ma'am. Good afternoon.
Yes, yeah, I can listen you, but can you just share your screen and begin the presentation?
Yes, ma'am.
Thank you, Preet.
No, this PPT won't work, Preet. Are you doing it from phone?
Yes, ma'am.
It's not visible. Just try fixing this. No. Till then, I think we can call the next. Just try fixing this because the PPT is not visible on the screen.
Okay, ma'am.
Yeah, try doing it. We'll wait for you till the end. Let's see how it works. So we can call the next presenter. It's Padmanan Abha. Ma'am, if I'm sorry if I'm spelling it wrong, it's Padmanabha.
Padmanabha.
Yeah.
Yes, it's Padmanabha Ital.
Yeah.
Yeah, hello.
Padmanabha.
Yes,
In
you
that
can
case.
start with your presentation.
Yeah, are you able to hear me? Hello.
I'm able to hear you. Just start sharing your screen.
Yeah, sure. Yeah. Are you able to see the slides?
Yes,
Hello.
I am able to. Yeah.
Yeah, good afternoon, everybody. So I'm Dr. Padmanabha Ital. I am Professor of Technology Management at Mukesh Patel School of Technology Management, NMIMS University, Mumbai. So these are my co-authors for this paper that is on Industry 4.0. So that is overview and further research directions. So just whatever the time allotted to me, 8 minutes, I tried to complete my presentations. So let us looking at what is Industry 4.0, and after that, I'm going to talk about what are the things we have done for Industry 4.2, what are the research papers we have collected, and what study you have done for this topic. So overall, if you look at the Industry 4.0, it is commonly used for the fourth industrial revolution. So just to put a background of the entire thing, so there are actually three earlier industrial revolutions. It started with the invention of the steam engine that we call as, and the subsequent the changes in the transportation that we'll call as the first industrial revolution, followed by the advent of the assembly line production by the Henry Ford, So that is in the late 19th century, early 20th century, that is called the second industrial revolution. And subsequently, the invention of the microchips, semiconductors, and these electronic gadgets, that we'll call as the third industrial revolution. So now we are actually at the cusp of the fourth industrial revolution. So that is the entire industrial scenario is actually going for a change with the new technologies coming up, and that is actually completely changing the industrial scenario, the way the product actually being manufactured, the service being delivered. So everything actually going for a sea change. So if you look at the industry 4.0, it is basically talks about the Internet of Things. Again, I'm going to talk about industrial Internet of Things. That is, again, we are going to take a combination of Internet of Things and actually Internet of Services also, how actually that can be put together to make things work for a plant or actually the factory. And the second important things which I put it on the slide is Industries 4.0's design emphasizes worldwide machine networks in an intelligent plant environment. So it is completely the machines are actually equipments we make to talk each other. So definitely with the help of the cloud networks and all. And moreover, it is the ultimate exchange of the data and control. And even whatever said and done, each machine is independent. It can actually pass on whatever the instruction to the other machines, and it can get the work done. Actually, definitely it can get the work done from the other machines or the equipment. So that is what is the scenario that is actually the future scenario when you're talking about Industry 4.0. And what is the major advantage actually? Why you are going for this Industry 4.0 is there is a huge productivity gain. No doubt, actually, we are having the productivity enhancement, or actually the productivity, that is whatever the improvement that is happening in the industry. But actually, we want much more than that, because no doubt actually we are going to make use of the real-time data in the industry, but actually that is not completely utilized. So that we want this Industry 4.0 in order to see that there is a drastic or actually the radical changes in the way actually we work in the typical industrial scenario. Now, some more points actually just I'm put it as part of the things we are done for this the paper. So in Industry 4.0, why actually the need? Again, I'm going to stressing the need for the Industry 4.0. So machines gather evidence from the other machines, and not only just it is limited only for the organization's particular plant or the factory where per se we are talking about. It is I'm just talking about the entire supply chain. So it may be a supplier, distributor, maybe the manufacturer or retailer. So we are going to look at the entire supply chain. Ultimately, we want to see that actually what is the value enhancement that actually happened for the entire supply chain here. So the one more thing also, the modern factories are in the phase of the technological transformation. So whatever the technologies that you may be finding, it may be related to the big data analytics, it may be the cloud computing, it may be the autonomous robots, or it may be related to the augmented reality. The new number of the technologies actually been coming up. So that is actually definitely going to change the way the factories will going to function. Not only just the factories or the plant, actually, I'm just, it is going to affect the entire supply chain, how the things are getting procured and how it is being manufactured, how it is distributed, and at the end, actually, how it is being given to the customer also. And moreover, the one more thing also, that is why we want actually more flexibility, because customer wants more and more product types, or actually more product variety. And we are already having the concept like mass customization of the products and the services, but still actually we want to go long way in order to satisfy the customer, see that his and actually her each and every requirement has been met. So in that context, we want actually more flexibility that is built into the system. So the system should respond in such a way that it should able to capture each and every requirement from the customer, and accordingly the manufacture has to be done. So the more focus on the flexible systems, so that is also required as part of this Industry 4.0. And workers at the manufacturing center can become coordinators. So now I think we don't want actually burden workers too much, operators, workers, or actually the supervisors in a typical plant too much with the instructions or actually maybe the data. So they are just the coordinators. They are just the link-ups between the two different things, maybe the machines, maybe set of the operators. And ultimately, we want to see that the entire work is actually, the culture is actually going to improve in the factory floor. And ultimately, that is moving towards the better work-life balance. So in the years to come. So that is also one more need. So that is for also the Industry 4.0 is required. Now, what you have done as part of the research, just I'll take 1 minute just to highlight the important things here. So aim of these studies to offer the outline for the research conducted in Industry 4.0 to identify the difficulties and problems, basically what difficulties and problems, especially in the execution of the industry, particularly how it is being adopted, how it is being implemented in a typical industrial scenario, and what actually gaps exist as far as the available literature in this area and what is happening in the industry requirement, basically what the industry requires. So that actually we want to study it, and we did it that to some extent. And we did the systematic literature review of the entire thing here. And more than that, we outlined the prominence of the research industry and further research, exactly what is the area that has to be explored. Also, we actually just included as part of this research. And overall, actually put it at just again, I'm going to rush through because of the paucity of the time here. So ultimately, when I talk about Industry 4.2, visualize the digital enterprise. So entire thing is on digital platforms. We want to actually make use of the maximum utilization of the data information that is coming in, and it is strategic. That is the long-term objective of the entire enterprise has to be fulfilled here, strategic in the nature. And more than that, it is going to develop the situation of the market and the business performance to achieve the objective of the organizations in such a way that, so ultimately, we are going to see that it is going to the improve the industrial efficiency.
Dear
It's all about what Industry 4.0, but definitely a lot of things are actually going to support it here. So just I'm going to highlight the important components of Industry 4.0. So most of the things are actually, you are aware of it, just highlight the important things here. Advanced algorithms are required in order to make it happen. So Industry 4.0. So unless you have got actually the advanced algorithms, so that is not possible. So yesterday also one of these keynote speakers was talking about the different type of the algorithms that is been, but actually we want much more sophisticated advanced algorithm in order to make the Industry 4.0 happen. So big data analytics. So a lot of data has been captured by the industry. When we're talking about maybe the factory data, or actually maybe the supply chain, or maybe the different areas related to the industry. A lot of data is captured on a daily basis. The question is here, how we are going to make use of data and how we are going to get the maximum information, and that can actually help in the decision making also. Those things also is required here. And autonomous robots also, it is already there, but actually making the robots actually more and more intelligent, actually make the task simpler, and actually just self-autonomous. That is basically they are going to manage themselves. Those kind of things also that is required here. Simulation, business simulation or the industrial simulation. Here the real-time data is actually taken here, and according to the simulation is done, whether it is really going to give the right perspective for the industry or actually the factory that has to be run. So what are the ways, so what are the different options available for the managers? So that is also one more thing. Horizontal and the vertical system integrations, when you are talking about horizontal, basically talks about the entire supply chain. Vertical talks about within the organizations, how the things are actually being tightly, actually how they are going to operate, how we are going to transfer the data and make use of the entire data that is available. So industrial Internet of the Things, I just told about it. It's not just the Internet of the Things, because we want to actually look at the Internet of the Service also to try to put it together, how that can be used better for any kind of the industry or the factory. Cyber security, most of the things, the security is one of the important aspects that should be also taken into consideration. Cloud computing, so that is actually going to pay big data in order for the storage of the data, then the data, how it is being manipulated, how the data actually put for the maximum advantage, and all those things done with help of the cloud computing and augmented reality. So the one more thing also that is required here, the operator's instruction shouldn't be, just I mentioned, shouldn't be burdened with too much information here. So that should be augmented reality actually going to create a virtual reality situations in which the instructions are actually available to the operator as and when he is required. Because if he is getting to let us say some kind of the preventive or the predictive type of maintenance, so instruction comes in actually when he's going to start looking at a particular maintenance activity. So it is been streamed to that particular after he can definitely use some other devices or actually gadgets in order to do it. So that is going to help in order to reduce a lot of work for the operator. So these are actually 7 to 8 important things that is been ultimately going to realize the Industry 4.0 in a big way in the future. And some of the things, again, I'm not going to elaborate. So everything is contained in the research paper. Social impact is going to entirely change the society, the work. It is going to, the people work in a particular way, their livelihood, the entire economy, GDP, it is going to completely transform. Definitely it is good for the developing countries who actually want to make a sea change in the way they are actually the competitiveness of their companies, or actually maybe the productivity. So that is going to help them to achieve these things in a big thing. And impact on the business environment, also entire business environment, the way you try to connect to the customers, the way you try to connect to the stakeholders, the way you connect to the government agencies.
We have already taken 10 minutes. We are
going
running
to change here. So that is also a major, again, I'm not going to get into the details. So with this, just I'm taking one more minute to just wind it up. So now with all these things, implementation of the Industry 4.0, if you look at, so what are the things required here actually for the implementation? The first one is industry shall prepare for a financial and the cultural impact. So this is going to change the way the people actually going to work, the people actually going to live in a big way. So you have to majorly look at actually financial and the cultural impact of the implementation of Industry 4.0. And again, the implementation of the cyber physical system. So usually we are going to call it as the cyber physical system. The physical systems, when combined with actually the data, internet, and all those things, that is how the things being transferred here. The big data analytics create a new avenues for the product and the service quality. Also, new type of the products that is coming in, we call it as the intelligent products. So the product that can organize themselves, and definitely you want actually the different type of the process also. And there is a huge improvement in the quality. And more than that, actually, just if you talk about though the large industries can design the strategy because they have got the deep pockets, they can do it much better. So the problem basically is the SMEs. So how they are going to manage with this kind of, they definitely require a different strategy for the implementation. And main prerequisites that if you talk about Industry 4.0 is the developing the new self, because the workers or the employees require a different new skills of set skills only. That is where actually that is being done.
So,
Hello.
very good. Hello.
Yes,
Yes.
Paras, any questions?
I just want to know one thing, Mr. Dr. Padmanabh.
Yeah.
As while we are talking about the Industry 4.0, it is stated that Industry 4.0 is optimizes the computerization of Industry 3.0.
Yeah.
So have you studied something related with this while you were writing this paper?
Yeah, some of things that is contained, because I couldn't able to cover because of this paucity of the time, it is contained in that paper. So definitely it is going to optimize certain things that is not available at the present scenario.
Okay. So how this computerization can take place in 4.0 while we are saying that we are optimizing it, so that means certain parameters and certain factors on which we can say this. So exactly I want to know, do you have any idea about those related things while you were writing this paper?
Yeah, no, computerization, that's one thing, because automation has already happened. So there is nothing new about, but actually the question is here. So it is the intelligent automation or not? See, what are the things we have done, the routine jobs, we already automated it. So if you go to any typical factory, or actually that is already being done. The question is here, whether whatever the intelligent automation we are talking about, whether they could able to help in the decision making to the maximum extent, so that the interference from actually from the operator actually being the minimal. So that is where actually these all this new set of the algorithms are actually that is actually going to help us. So that is not being done. So there actually we are going to look at.
Because you have mentioned in your presentation that it's meeting like fast changing needs of customer industries through the flexible system. So we must know that how this flexible could be derived. That is what the objective behind that question. Okay, thank you very much, Dr. Padmanabh. Anything else from other?
The participants can drop their questions in the public chat forum, which is open for all. Yeah, thank you. Thank you. And so we'll move on further. Preet, are you here? Preet? So Preet is not here. We'll go with Hala. Hala?
Yes, ma'am. Yes,
You're
ma'am.
ready, right?
Yes, ma'am. Good afternoon, everyone.
Good afternoon. So you can share your screen.
Okay, ma'am. It's visible, ma'am?
Yes, I can see your screen.
Okay, ma'am.
You can start.
Okay, ma'am. Good afternoon, everyone.
Please take care of the time frame. We cannot allow you to take too long. We have other participants waiting as well. So please go accordingly. 8 minutes for the presentation. That's it. Thank you.
Okay, 1 minute. 1 minute. Just 1 minute. To full screen. Just 1 minute, ma'am, please.
This is PDF, I suppose. Do you have the PPT or PPS?
Actually, I created by LaTeX, sir. That's why. Okay, sir. Good afternoon, everyone. Our research paper titled Credential-Based Authentication Mechanism for IoT Devices in Fog and Cloud Computing.
But your screen is not visible,
Sorry to
Hala.
interrupt. Yeah, that's what I
Yeah, what I can do is you just come back again and move on to the next presenter. Just sort out this issue and come back.
Okay, ma'am, sure.
Okay. So Padmaja,
I think Preet is ready, so we can take.
Preet is ready. Preet is not responding. So.
Yes, ma'am.
He's
Preet, are you
mentioned in
ready?
chat box.
I'm just sharing the screen from my laptop now.
Okay, you can start. You will be
Thank you.
presenting on communication skills, an integral instrument for data analysis in the field of medicine.
So, shall I start, ma'am, or
Yes,
wait for
yes.
the next?
Hala, you will come after Preet. Yeah, Preet is
Okay, sure.
presenting.
Okay, ma'am. Okay.
Sorry about that. Speak faster, please. Preet. We'll move on with the next presentation. It's Padmaja. Padmaja, are you audible? Can you hear me?
Hello.
Padmaja?
Hello, ma'am. Am I audible? Hello.
You are audible, but you are not able to share your screen. I'm waiting for that. And that's time consuming
Ma'am,
right
I
now.
am I am from the next group you called for Padmaja Sawant, but I am the co-author Isha present.
So are you going to present on behalf of Padmaja Sawant?
Yes, ma'am.
She is not going to present?
No, ma'am.
Your issue, right?
Yes, ma'am. I'm Isha Bartak. I don't know the name by mistake. Instead
It's
of
Isha. Tell me your full name.
It's Isha Bartak.
Okay, you can start. You're presenting on detailed review. No.
Yeah. Yes, ma'am. Detailed review of test extraction using.
1 second, just a
Preet, you
minute.
unshare your
There is
screen
a-
first.
Yeah, please. Yeah, that's what. So right now, Preet, Padmaja, instead of Padmaja, Aisha is presenting. So please wait for her and then you just sort your issue and come back, please. Padmaja, you can start. Issue, you can start.
Yes.
Share your screen. Share your screen, please.
Yes, ma'am. Ma'am, is my screen visible?
Yes.
Okay. Ma'am, shall I start?
Yes, you can start, please.
Good afternoon, everyone. My name is Isha Bartak, and today I'll be presenting the proposed review paper titled Detailed Review on Text Extraction using Optical Character Recognition. So today's agenda is going to cover the following topics throughout the presentation. Beginning with the introduction. So as we all know, there exist businesses and applications that involve huge amount of data generated, be it in any form, to be processed and stored on daily basis. So it is an implicit requirement to be able to carry out a quick search through this enormous data, and documents and all the data of these documents is being digitized in all possible fields, as collecting the required data from these documents manually is very time consuming as well as a tedious task. In order to automate this process of data collection and entry, optical character recognition was introduced. It is used to recognize the text that is required to be extracted from the scanned documents such as PDF, JPEG, handwritten, etc., and convert it into machine-readable text and store it in some target format. The capabilities of OCR provide endless possibilities throughout the entire industrial spectrum, covering banking, healthcare, education, legal, etc. Coming to the literature review, in order to carry out the review, we did some research and based on the research, we found out information regarding OCR and its associated concepts, for which the main source of information was through papers published through international conferences, international journals, etc. Now we'll come down to the findings from the review, which include the following topics, such as the OCR plus process flow, the OCR methods, data extraction from specified documents, OCR platform, etc. Coming to the OCR process flow, it basically describes the step-by-step procedure of how OCR takes place, and it involves the series of steps beginning with image acquisition phase. So during this phase, the recognition system collects a scanned image as an input image, which can be of different supported formats such as JPG, PNG, etc., which is captured via a scanner, a digital camera, or any other compatible device. The next step is of pre-processing, where the image is subjected to a variety of activities. Binarization is one of them, which uses the thresholding approach to convert a grayscale image to binary image. So in this process, the image is basically improved and made ready for the segmentation. In segmentation, an image of a series of characters is divided into sub-images of individual characters in the OCR system by employing a labeling procedure to assign a number to each character. Here, each character is scaled to a standard size of 30 into 20 pixels. The next step is feature extraction. So in feature extraction stage, each character is represented as a feature vector, which becomes its identity. The main goal of this step is to extract a set of features which maximize the recognition rate and can promise as good accuracy. The classification stage. So basically, this is the decision-making stage of OCR recognition system that uses the feature that have been extracted in the previous stage to recognize a text segment according to the preset rules. And the last and the final step is the post-processing. Basically, it computes the equivalent ASCII value using the test samples recognition index and showcases the relevant identified characters in structured textual format. Our next topic is the OCR methods. So many researches have been conducted in an attempt to recognize characters, forming varied combinations of techniques to achieve higher accuracy. Among a wide variety of methods for performing OCR, the prominent ones are listed below, beginning with the matrix matching method, where a matrix is created for each character to find a particular pattern. This pattern is then compared with all the indexes of the known character. Then another method we came across was fuzzy logic. So this strategy generates an output with multiple values in contrast to the binary values, which is 0 or 1. Fuzzy logic signifies a more humanistic approach to logical thinking rather than binary-based computers, and it is most appropriately used for PDF documents. Another method is extraction of features, where every character is constructed by mentioning presence or absence of some essential features like excuse me, like height, width, density, lines, etc. Mostly magazines and high quality images are suited for this type of method. Another method is structural analysis. So in this method, the image shape, sub-vertical and sub-horizontal histograms help to detect the characters. This method helps to repair damaged characters as well and is very well useful for low quality text and newsprints. Another method is of neural networks. So neural networks are based on human neural system. The pixels in an image are compared to an index of familiar character pixel pattern. It has a great character abstraction capability, ideal for fax documents or distorted text. Our next topic is data extraction from specified documents. As documents generated belong to different forms according to the need and usage, based on the research work done, this chronicle illustrates how data is extracted from respective formats or different types of documents that are available in the industry. So beginning with the exam answer sheets. So the extraction of data from exam answer sheets, the process. So this entire process starts with pre-processing of the image, which is captured by the video graphics array VGA camera, followed by the adaptive thresholding, which captures data from the answer sheets, which is then passed on to the OCR system, which converts it into a machine readable format and generates an Excel sheet of the same, and hence provides a unique approach for developing an automated system that can quickly recognize marks or any other data from exam answer sheet and store it in a host computer. Print bills and invoices is our next, where so there's a methodology for extracting any data from printed bills and invoices, such as bill amount, schedule date, similar data, and in order to obtain sufficient information about the user's purchases and transactions, as well as their likes and dislikes. Newspaper and comics is another type of document. The text can be detected and extracted in images automatically, which have been collected from varied sources like newspapers, video ads, photographs, and text, etc. And another of a final type of document is multilingual documents, where documents have information in different languages. So the following processing stages are proposed for a typical multilingual documents OCR system, which include binarization followed by layout analysis, page segmentation, then pre-processing, last and not the least, but feature extraction and classification or recognition. Our next topic is the OCR platform. So many data scientists have tried to develop different efficient and accuracy trusted OCR engines. Now let's give a look at a few which we have overviewed. Beginning with Google Docs OCR, it is an easily available OCR facility proposed by Google, which will automatically perform OCR by generating an output file in formats such as PDF, text, doc, HTML, etc. And apart from this, it also supports 30 languages and provides us with good OCR services. The next one is Tesseract, which is again an open source engine which focuses on recognition and has the capacity to recognize over 100 languages. Tesseract also supports a variety of output formats and give us good OCR results. Another one is Abby Fine Reader, which is another OCR engine that an international company named Abby designed and developed, which provides efficiency in OCR. And another one is Transgene, which is another OCR solution which helps in obtaining precise and accurate information from digitized documents in Transgene, which is offered as an SDK with a high-level API as well as a software package with simple GUI. Our last one, which we overviewed, is I2 OCR. It is a freely available online OCR tool which first extracts text from images and then converts it into text format, which can be later edited, formatted, indexed, searched, or translated. Coming to the future scope, OCR holds innumerable possibilities in future. Some have been overviewed, such as it can read screenshots supporting complex formats. It can also be combined with artificial intelligence to auto-extract information from scanned receipts. It can also facilitate development in fields of robotics. Furthermore, OCR can be integrated in antiviruses to catch viruses by detecting codes and provide to be a very trending technology as we proceed. Coming towards the conclusion for today's presentation, the proposed paper describes a detailed overview of general extraction methods from different types of documents with different forms of data. And in addition to this, we have also illustrated on various OCR platforms. The current study is expected to advance OCR research, providing better understanding and assist researchers to determine which method is ideal for OCR. Hereby we conclude the presentation. Thank you.
Thank you, Isha.
Ma'am, should I stop sharing?
Yes, please. Sir, any questions?
Sure. I just
Yes,
just wanted to know, is there any real-time scenario where we can use this data extraction methodology through OCR, especially in the industry area?
Sir, so what we came across is it is recently being used by government to like scan Aadhaar cards and get the information for their like government purposes. So they are using it for that purposes. What we came across while reading. It's used by the government for the Aadhaar card scanning and extracting information data. Also, there's this DBS Bank, which is a Singaporean bank, and they have developed their own OCR software to provide on-the-go loan approval. So basically, they take all the important data from all the important documents from the customers. They put OCR in it, and they validate the data, and then they provide on-the-go loan approval.
Did you analyze these different softwares? Which one is providing the more accuracy or something like that? While data extraction is there.
Haven't really done the comparison as such, which is like more more which one will be more, but one thing we read about Tesseract was it provides around 95 to 96%, 95 to 97% of accuracy, but others I'm not very well sure with the figures.
Great. All the best. Thank you.
Thank you. Thank you so much.
Thank you, Aisha. Preet, yeah, now you can share your screen. Yeah, please
Sharing
start.
the
Please start. Your screen is
screen.
visible.
I just wanted to confirm.
Yeah, please, you can start.
Is it
Like there are participants who are waiting
visible?
for their presentation also,
Because
and we are running a lot of time.
I'm not
please.
able.
I'm able to see your
Yes, yes, we are
name.
able to see, but I think you are having some internet issues because
Yeah, please
your
sort
voice
that
is
and
also
come.
breaking and it's not. It has taken time.
Yeah, please, because there are participants who are texting me and telling that because their time is for presentation has gone.
So what I
Please.
suggest, Preet, you just check all these
An
issues and
integral
then come
instrument
to
for data
presentation.
analysis.
Okay, start.
Start, please,
Sure.
start.
Sure, sir. So I'll go by the contents first. I'll be firstly introducing the topic, which is communication skills and integral instrument for data analysis in the field of research. Next, I'll be talking in brief about the research tools and methodology. Third will be action plan, next data plan, and then coming to the conclusions and suggestions. So beginning with the introduction, I would like to share that as the name of the topic says communication skills. So herein we have tried to show that data analysis and communication skills, they just go hand in hand. So if
Sorry to interrupt,
communication,
Preet, but please run your presentation instead of showing in the application. Press F5 and please run your presentation.
okay, sir.
Okay, if it is taking time, so please carry on with this. No issue. Carry on.
All right. Thank you, sir. So I would like to continue that we have basically tried to find out that if communication skills are good, or if one has if a research scholar has a good command over language, then the expression of the methods of research becomes very easy. So basically, not only the technical knowledge matters, but the communication skills are also equally important. So I mean, if we have a good command over language and good communication skills, so it will be a positive connotation whenever we try to come up with the data analysis. So what we have done in this study is, it is basically an empirical study. We have taken a sample size of 30 research scholars. So all the research scholars are from technical background, master students. So what we've done is we have introduced them to SWOT analysis, that is strength, weaknesses, opportunities, and challenges. We have made them aware about the basic parts of speech, which is the beginning of grammar, that is prepositions, nouns, pronouns, and things like that. So we have also made them practice a few activity sheets. A lot of worksheets were given, and basically the research happened in two phases. The first phase was in which the interviews were taken, and the second phase was in which the feedback was taken. So in the interviews taken, we basically got to know the problems faced by the research scholars, and we try to work on their problems by giving them practice sheets, and similar visual stimuli were given to them. So with this, it helped improve their skills, and with this, we came up with the analysis that there are also some samples of worksheets which I've added in the presentation. As you can see, a diagnostic sample diagnostic test. So with the data analysis of pre-application, that is in the phase 1 interview findings, and post-application, that is in the phase 2 interview findings, the improvement was about 44%. So which is significant that one, when improves their language and is good with grammar, so it'll obviously help the candidate in making a better research proposal. So it was observed that the research scholars basically focused on the technical domain, from collection of data to its interpretation and visualization. But once they were made aware about the basics of parts of speech and then SWOT analysis and various other worksheets which were formulated for their practice, and so after that, a significant increase in the percentage of their expression was observed. So it indicates that importance of an English language in teaching, learning, in oral and written is very important for quality research work. So now I would like to conclude by coming up with the conclusions of the research and the suggestions, the probable suggestions. So the researchers here, when we did these survey for 30 students, all from technical background. So what we came to know was that there were poor visual stimuli among researchers, which resulted into ambiguous data interpretation and vague result output. So by comparing the results, we found that the research proposals were improved and the expression was better than before after introducing such activities related to communication skills with the research scholars. So this study basically reveals that there is a subtle but direct relationship between communication skills and data analysis in the field of research. So there is an unseen thread of communication skills that helps to weave the technical findings and the analysis. So that is all. So thank you.
Okay, thank you, Preet.
Thank you.
I think
Thank you, sir, for having me.
So we have our next presenter, Hala Ali. Hala Ali.
Oh, yes, ma'am. Yes, ma'am.
Yeah, you would be presenting on credentials.
I will present fast because no power here in my laptop, so I will try to present fast. But just give me 1 minute. I don't know why it's not coming off. No. Yes, ma'am.
Start sharing your screen, Hala.
Oh, okay. It's visible now?
Yes, it's visible.
Okay. Good afternoon, everyone. Our research titled Credential-Based Authentication Mechanism for IoT Devices in Fog Cloud Computing, presented by me, Hala Ali. So outline, introduction, related work, problem definition, system model, contribution, our proposal, performance evaluation, conclusion, and feature work and references. Introduction, IoT devices actually utilize the cloud computing because of its unlimited resources. Fog computing is considered as extension of cloud computing by shifting the services close to the IoT devices. IoT devices also are restricted resources, restricted devices, and that's why all the security operation offloaded to the fog layer. This work introduced a novel credential based on authentication mechanism of IoT devices at the fog layer. Related work, many authentication mechanism has been proposed based on TLS protocol or mutual authentication between the fog and the cloud layer, or between the IoT devices and the fog layer. This work actually implement a central authentication mechanism of IoT devices at the fog layer based on the attributes of IoT devices, and to implement the privacy preserving confidentiality and authentication. Problem definition: interaction of IoT devices with the fog layer leads to many security threats in the execution environment. IoT devices have a limited resources capacity, that's why they cannot do or secure themselves. That's the operation of the fog layer, keeping the privacy preserving of IoT devices in one of our aim. 1 minute.
You are not audible, Hala.
Hello?
Hello?
Yes.
Yes, can you hear me, ma'am?
Yes, I can hear you.
My presentation is visible now?
Yes, it's visible.
Okay, okay. I'm sorry. Here and ensure the data and key secure distribution between the fog and IoT devices. Also, it's an important challenge in this world. In this work, attacks try to compromise the IoT devices to launch their attacks to on the processing devices at the fog and the cloud layer to attack the fog and the cloud devices. So we aim to authenticate the IoT devices at the fog layer before serving them by the execution environment. System model, the architecture includes 3 layers: cloud and fog and IoT devices layer. Fog layer consists from 2 types of fog devices: fog broker and fog server. Fog broker is a central node responsible for resource management and key and credential generator and for authenticate the IoT devices. Fog server is just processing node. Data center at the cloud layer also a processing node with unlimited resource capabilities. IoT devices has like many types of IoT devices, like such as smartwatch, robot, and camera, CCTV camera. IoT device is defined by IT, username, ID, username, password, and shared secret key between the IoT and fog layer. A private and public key generated by the central node fog broker, and the credential also generated by the fog broker. Each fog server is represented by ID, private and public keys. Also, the fog broker is represented by ID and the private along with the public key. So our contribution proposed a centralized authentication mechanism based on the attribute of IoT devices, establish a secure distribution of the key between the fog and the cloud layer, and validate the efficiency of the proposed approach in terms of confidentiality, integrity, privacy preserving, and detecting the compromised devices. KCG key and credential generator at the fog broker has information about all the IoT devices and fog devices. The private and public key of IoT and fog devices generated by the KCG. And the fog servers has registered information about all the IoT devices connected with. So our proposal here, the IoT devices send its attribute encrypted by the public key of the fog broker to generate the credential. KCG will generate the credential and will generate the secret key sharing between the IoT and fog server encrypted by the public key of fog server and public key of IoT devices. So the IoT devices request the KCG to generate the credential. KCG will generate credential and secret key and distribute the secret key between the fog and IoT devices. And then IoT devices can submit the credential to fog node. Fog node will verify the credential. Then after completing the authentication, the authenticated devices will be served by the fog and the cloud layer by scheduling their task. So the first algorithm, gradential generation algorithm, it will be done by the KCJ. So the first step, calculate I1. I1 is just hash value of the hash secret key along with the attribute username and password and ID of the IoT devices. Calculate I2. I2 is the hash function of I1 with the hashed ID of IoT devices. Calculate I3. I3 is this item is the encrypting of the IoT devices attribute. I3 start is a one-way accumulator hash function, and I4 is the validation time of the credential and signing all of this items by the private key of the KCJ. Credential verification at the fog node. Calculate I1 based on the registered information about the IoT devices in its database and comparing with the received I1. Also I2, calculated I2 and comparing with the received I2, even I3 to check the validity of the secret key. Calculated I3 start, checking the validation time of the credential and verify the signing using the public key of the KCJ. Then simulation environment, it has done by using iFoxSim simulator with the GCA Java cryptography architecture. And
sorry to interrupt you, but you have last 1 minute.
yes, sir. Okay. And our used algorithm data encryption RSA and hash function, secure hash function 256 bit. So implementation, our existing, we have like consider some compromised IoT devices. KCD will generate a shared secret key. Attack will modify some attributes of the device, and by this experience, we'll see how we can detect the changed attribute by the attacker. So the proposed like password here, attack change the password from password 1 to halabas, for example. KCJ first, it's like just screen shoot from the simulation result, how to generate the credential and secret key. The second step, encrypted the secret key using RSA algorithm and distributing between the fog and IoT devices. Receiving the secret key by the IoT and fog and decrypting to get the plain text key. Then fog server will receive the credential by IoT device and will check the registered password is password 1, but the received password is halabas. So means some attacks there compromised IoT devices. So this device is not authenticated, and by this way we detected the attack. Conclusion, we have proposed authentication mechanism to secure IoT devices and depend on the attributes of IoT devices, and we have implemented privacy preserving by hashing the attribute of IoT devices. So these attributes will be transferred as a blinded value. Simulation experiment show how the proposed mechanism ensures secure distribution of the secret key, protections the device from eavesdropping, in addition to detect the compromised IoT devices. Future work, we plan to implement the proposed mechanism in real environment to analyze the system behavior and compare it with other authentication approach. Another direction is to optimize our method to reduce the security overhead. Furthermore, consider the mobility of IoT devices via implementing a mutual authentication between the fog server as a fog layer and the major references. Thank you.
Okay, thank you, Hala.
Thank you, sir.
So we may proceed with the further next one.
Okay. Shubham Singh.
Good afternoon, everybody. I hope everyone is doing safe.
Yeah, you are ready, right?
Yes, ma'am. Can I share my screen?
Yes.
Already shared.
Is it visible?
Yes.
I am Shubham Singh. I am here to present my paper, that is Disaster Net, Multi-Level Disaster Aftermath Image Classification Model. The main motivation of this project is to provide a potential solution to increase the speed of rescue operations by predicting the disaster severity of a particular location. To achieve this, we have created a neural network and trained it on our custom dataset such that it can predict the severity of the damage caused by natural disaster efficiently. And we can also provide a potential pre-insight for the rescue workers before the before the rescue workers deploy to the affected area and actually start their work. The whole process walkthrough for this paper was to build a custom data set. After building it, we performed some data pre-processing and augmentation steps such that we can make our dataset efficient for training, and then we trained our neural network model using that dataset. The dataset that we have created was actually a custom dataset that we have created by downloading disaster aftermath images crowdsourced from various online image hosting platforms like Google Image, Flickr, etc. After downloading that dataset, we have to label those datasets. And for labeling, we maintain this particular structure. Suppose an image is downloaded, then we first divided that image into two classes based on the type of the image. That if the image has buildings in it, then we put that image in the building class, and if it has crop fields that defines agriculture, then we put that image into the agriculture class. And then the images which had buildings in it were further classified into rural and urban based on their localization. And after that, based on the damage caused in those buildings, they were further divided into no damage, mild damage, or severe damage. And similarly, in agriculture also, the images were further divided into no crop loss, and flooded based on the damage that has been caused in the field. After dataset labeling, next comes data preprocessing and augmentation. We resized the images that we have downloaded into 256, and 3 dimensions, and then we normalize those images such that we can train our model efficiently. And then to increase the size of the data set so that our model can be trained well, we introduce few random data augmentation processes like random flips, rotation, zooming, etc. And then after our dataset is being created, comes the model architecture, the model that we have used to train that we have trained using that dataset that we have just created. The base network of our model is MobileNet V2, which was developed by Google. We use this network as a fixed feature extractor to extract meaningful features from our custom datasets. And then we freeze the entire network of it and replace its 1000 class classification block with our own multi-output classification block based on the classification that we did while defining our dataset. The optimizer that we have used is NADM, which have both the properties of momentum-based gradient descent as well as adaptive moment estimation ADAM that for better convergence. And the output function that we have used here is sigmoid for the classes that had binary classification and softmax for the classes that had multi-class classification. And the evaluation matrix that we have used is for our prediction and to do the comparative study is F1 score. The main abbreviation of our model is that it provides 3 basic advantages. It has a very small memory footprint of only 64 MB. It takes very less inference time, as mobile network was basically designed for low power and resource constrained devices. And it is easily deployable as it takes very low memory and it takes very less inference time. The requirements of the whole paper was for the project just a basic laptop that we have used, and we performed all the training in Google Colab. The programming languages and frameworks that were utilized were Python 3 and TensorFlow and Keras. The evaluation matrix that were used was F1 score, which is the harmonic mean of precision and recall. And here is some comparative study. As we have used our custom data set, so we cannot directly compare our model or our paper with any other present models or papers, because as we all know, the efficiency of a model is directly proportional to the data set. But still we have gathered some related works, and we can clearly see that our model took only 62 MB, whereas other models take more than the double, and we still was successfully provided some efficient results. Now, this is the whole idea of our potential solution. First, the disaster strikes. And after that, as we all know, we all are very much involved in social media. So social media gets flooded with post-disaster images. First, we will collect those images by from different geolocations and upload to a cloud-based service for interferencing. After inference is done, we will alert the disaster management team, providing them the details with the severity and the damage of the location, so that they can pinpoint the exact location and perform accordingly. This is some of the results that we are showing of the predictions that our model did. We can clearly see this is an agricultural field which is flooded, and at the top this is the actual level of the data set, and this is the predicted level, which is in green color, agricultural and flooded. And similarly, all the other three images, we can see that our model is performing almost efficiently to 100%. So to conclude, I would say that the proposed method is very lightweight and can provide a pre-insight to the rescue workers and the first responders before they deploy to the actual zone with the severity of the damage caused by the data that our model will provide. Thank you.
Okay. Thank you, Mr. Shubham.
Thank
Can you brief us on the role of GIS and GPS in your this disaster net model?
Yes, sir. Actually, whenever we are uploading any picture on any social media platform, it has a location tag. So if we can pinpoint some particular location and download only those images after the disaster has happened, then we can use that location of that area, and we can find that images, and then if we use those images in our model to inference, then we can get a rough idea about the damage caused in that particular location.
In that case, that image should be uploaded in the well time. But it is taking time. Upload after 2 days, 3 days, then we can go with that.
Sir,
do we have any immediate sort of GIS and GPS in implementation of this?
Pardon, sir?
As you said that if the social media images are uploaded, suppose those images are uploaded after 2 or 3 days.
Sir, basically, this idea was completely dependent on the fact that we are globalizing and everybody is so much into social media that the moment something has happened, it just directly gets uploaded in the social media. So even if the image quantity is less, but the chances of there's no image in that particular location and something big has happened is very less.
Okay, again, we can say that there is a dependency of things. Everybody is available on this social media or some of the network from where they can access images.
Yes, there's no direct connection of GPS, but we are using the social media, so there is a dependency. But this is a process through which we can get a pre-insight. Like we all know that if something big has happened, it like within seconds it gets uploaded in the social media. And this idea was mainly oriented from that only because just last year in West Bengal we were hit by a cyclone storm Amphan, and everything was under lots of problem. And at that point only I noticed that even those who are suffering from it are making videos and uploading it on social media. So from there only this idea came that we can do this.
Yeah, that is one good thing, that you have one idea from the things where the people are just watching but not taking action. And I hope that your model will get success in that. Thank you very much and all the best. Good luck.
Thank you, sir. Thank you, sir.
You may proceed with the next.
Yes, yes. Thank you. Thank you, Shubham.
Thank you, ma'am.
So our next presenter is Nupur. She would be presenting on decoding visual covert attention shift from EEG for use in DCI.
Ma'am, are you able to see my screen?
Not yet. Not yet. Are you?
Yes, I am sharing, ma'am.
Just a minute. You have. Can you try now, Nupur?
Okay, ma'am.
It is popping up as Nupur has started sharing the screen, but I'm not
Ma'am,
able to view your presentation.
actually, ma'am, it's coming. Your screen sharing is post.
Uh,
एक minute, resume share.
Not possible because your screen is started sharing. Just need to stop on your screen.
Let me try again. Ma'am, now are you able to see?
Yes, I'm able to see.
Okay. Good afternoon, all of you. I'll be going to present on the topic decoding visual covert attention shift from EEG for use in BCI. So,
Ma'am, please make it full screen.
Sure, sir. Fine, sir.
Yes, it is.
Yes, go ahead.
Okay. So these are the contents I'll be sharing with you. The first is introduction. The second is the methodology that I have used for the proposed approach and the results, and finally the conclusions. So before moving, let's say what is brain-computer interface, as we are using the covert visual shift for brain-computer interface. So brain-computer interface is basically a device which provides a communication between the paralyzed person who are not able to perform some work. It allows to communicate with this external environment. So basically, it is a type of interface that provides a communication between the environment and the person who is not able to communicate properly. So there are different types of BCI. Generally, if we talk about on the imaging techniques, so we have invasive BCI and non-invasive BCI. And non-invasive BCI includes EEG, PET, fMRI, and invasive includes ECOG. So since we are using EEG signals, so I'll focus on EEG-based BCI, or basically on EEG signals. Basic EEG BCI are most widely used BCI, and EEG is used with the BCI applications because of its simplicity, portability, and low cost. It is easy to collect the EEG signals and without any harm. So next is visual attention. Visual attention is basically the attention that to see to see that particular object. So visual attention is categorized into covert attention or overt attention. Covert attention is the attention that we are concentrating on an image or on an object without moving our eyes. Like, for example, suppose our some object is at the left of the screen. So we have to see on the center on and concentrate on the left screen. So this is somewhat covert attention, that is making attention to a particular object without moving the eyes. And I am using this proposed approach for covert visual attention. Next is overt. Overt is simple attention that we we move the eyes here and there and we see the objects generally that we do in our daily life. Next is the method that we have used is the first is the Eeg recording, and the data that I have taken is the publicly available data set. Then we have performed pre-processing on it. Then we have performed a classification, and we have used convolutional neural network for classification. After classification, we have used some evaluation matrices, and the matrices that we use for evaluation is precision, recall, and F1 score. And at the end, we compare our approach with the conventional methods, basically the traditional classifiers like SVM and gradient boosting. So first is EEG recording. EEG recording consists of your 18 subjects, and it is the person has to react to the question as yes or no, depending upon the color, which is which will be presented at the left or right of the screen, and the visual gaze will be on the center of the screen. This is something about data. Then next is pre-processing. First, we have applied the bandpass filter, and the bandpass filter range is 1.1 hertz to 50 hertz. Then we have performed the downsampling and sampling. It is done. The sampling rate is 128 hertz that we have used. Since visual attention is related to occipital, or we can say we have different channels when we put Eeg device on our screen, on our head. So there is one region, that is occipital region, and occipital region is the region which is related to our visual attention. So we have used 19 occipital channels only for this processing. Then we have made epoch 4 milliseconds epochs at the start, that is 750 milliseconds after the start of the stimulus. And for all these pre-processing, we have used a software, that is EEG lab tool, which is available with MATLAB. This is the proposed architecture. These are the layers that we have used in the convolution neural network architecture. The first is the convolution. We have used two convolution layers, and the one is max pooling layer, then is flatten layer, and two dense layers. So this table gives the summary of the layers that we have used, its shape and the parameters. And dropout layer is used to avoid the overfitting. After every layer, dropout layer is used generally to avoid the overfitting. Then the hyperparameters that we use, since it is a binary since it is binary option, either yes or no, we have used binary cross entropy. Then the optimizer used is RMS Pro, and the batch size is 256. The experimental results, then evaluation, as I have already discussed, we have used precision, recall, and F1 score. Precision is tells about the positivity, that how many options are truly positive. Then same as recall, it is how many are negative. F1 score is the harmonic mean between the precision and recall. So here we have used two classes. We have divided the data and average that on the basis of two classes. That the answer, class 0 is answer was yes and the positive target was on the left, or if the answer was no and negative is on the right. Same is class 1, answer is yes and positive target is on the right, and if the answer was no and the negative target was on the left. These are the two classes, and it has been already, when we have used the data, it has been already mentioned.
Sorry to interrupt you, ma'am, but you have last 1 minute.
Yes. Okay. This is the performance version we have used. So class 0 and class 1, this is the precision, recall, and F1 score for class 0 and class 1. Then these are the plot accuracy plots and loss for training and validation, training and testing. And then the comparison we have used with measure, and for compare we use accuracy and area under curve. This is the this three classifiers. One is the proposed approach, and other two is SVM and gradient boosting. And it, as we can see from the table, that our approach has better accuracy as compared to the conventional methods used. So this is the ROC curve for the different classifiers that we have used or compared. And we can see that our approach is performing better. Then this conclusion is that the convolutional neural network has achieved the highest decoding accuracy towards the attention shift, and this can be used as an assistive device for the persons who have some eye movement impairments. So these are the references that we have used in the paper. Thank you so much.
Okay, thank you, Nupur. Thank you very much. We can proceed with next.
Thank you, sir.
Okay, sir. So next presenter is Manish Kumar Abhishek, and his paper title is a scalable framework for high performance computing with cloud.
Hello.
Yes.
Is it visible?
Yes, it is. Make it
Okay.
full screen and
Yeah.
start your presentation.
Hello all. Good afternoon. Thank you for providing me the opportunity to present the paper. I'm going to present a scalable framework for the high performance computing with the cloud. So agenda is that we'll go with a bit of the virtualization and containerization, Docker containers, container orchestration, scheduling algorithm, and the proposed framework. So as we know, server are evolved from long time. Earlier it was bare metal. Then we went to the virtual machines. Later on we shifted to the containers for their performance. So from the bare metal to the containers, servers took the long steps with on their performance. So if we talk for the background. Cloud computing work for the resource pool on which virtualization works, and HPC for the solving big computational problem, and it's for the R&D and other use also. So if we talk about the containerization, it is very lightweight, and it is having very light footprint on main OS, but it is sharing, and it's providing bit of the abstraction like a virtualization, but it's sharing the same kernel which is run by the operating system. And if we talk about the implementation scheme for the Docker or DevOps, it comes through the Docker image, which very lightweight image on by which we can span the containers, and from the registry we can download the image which we require, and the container itself have some life cycle. So we call it DevOps. But if we talk about the HPC is something like a scientific. So for that we need a performance. Always we need a performance. So if we talk about the HPC, we need InfiniBand clustering and very huge performance. We need a ultra high performance from there that's clustered and needed to use whatever the powerhouse, whatever the power they're having in the clusters. So we use GPU, we use high speed network, etc. But if we are planning to use HPC over the cloud, cloud itself talk about the over provisioning, better utilization of resource, and the footprinting and cut the footprinting. So basically they go for the massive provisioning. So whenever server is not required, they turn off, and we are tended to post more and more image on the one server. So HPC is going on different direction, and cloud is talk about always about the cost and their profitability. So if we wanted to merge both, we need to make some intermediate way. So my proposed framework by which we can place our container on the GPU based servers, and we'll check the quota by which this will ensure that wherever the container is going to be placed, that will be the fit for their that will be there for the base provisioning, and it will ensure that it is not go for the over provisioning of resource, like cloud is having their tendency to over provisioning of the resource, because they have if we have 100 servers in one cluster, might be 50 users not using that much of resource. But in case of HPC, we need to take care of that. So framework, we can took the image from the registry and check from the scheduler, and with the help of native Kubernetes cluster scheduler, we can patch our scheduler over that. And with the queue manager, we can provision the node on the required compute node, and through that cluster can be achieved, and high performance computing, artificial intelligence, or related kind of stuff could be done through this cluster algorithm. So if server is we need to check it out, either the server is having free core, free GPU available or not. If it there, then we need to place our container and recheck that there is availability or not. So it's going for the whole rack. So if we So it is going to distinguish that which server having GPU and which server is not having GPU. So on the base of that, we can place our containers on that host, and it will ensure that we can get the maximum performance from that server. Testbed configuration, we start testing with 128 CPU and 256 RAM testbed with a pod count of 100 and 500. And subsequently, we decrease the vCPU and memories to do the massive clustering and check the fit algorithm, how we can fit to the physical server. So after the placement, we got some result. So we started from 100 until 300. We got it stable performance, and it's gradually getting the performance and accuracy better and better later on. So this is the output of their placing algorithm through the KNN, kind of modified KNN. So we can see if we place the container with native Kubernetes, so it will select the whatever the host is best possible, and they place the container whatever the best coming host. So whatever the available host, and it is tend to use the resource as much as we can. But after the accuracy, we can see it is going to place the containers wherever the GPU is available, and rest it is getting free. Results, we got the results by which we are around 22% improvement over the normal Docker containerized environment. So on the conclusion part, we can cloud is not designed for the HPC kind of stuff. For that, we definitely require the clusters, but the things changing, and the big company like Google, Amazon, and Nvidia will start delivering the HPC solution through the cloud. So this kind of algorithm could be patched or could be available with existing Docker and Kubernetes, which is very popular in cloud space. And this can be the game changer for the normal users or normal student in the university, on which cloud and HPC can be coexist on the same cluster, and the experimental HPC could be provided to the every students or every developer, which on which they can go for the AI or other kind of stuff which natively require the HPC. Thank you.
Thank you, Manish.
Thank you, Manish. We may move forward.
Okay. So
Please
move
let
for
me
our
know if any question.
Sir, do you have any question to her?
You can unshare, Manish. Thank you very much.
Yeah. Thank you, and thank you for providing me the opportunity. Thank you.
Okay.
Do we have any more?
Yeah, sir. So next for our next presenter is Martin, and his paper is on risk reduction on rainfall induced landslides, a site-specific early warning system.
Hello.
Yeah, hello.
Can you see my screen?
Yes, it is.
Yeah, thank you, moderator, for this opportunity to present our research on risk reduction of rainfall-induced landslide, site-specific for early warning system. My name is Martin. I'm from Rwanda, University of Rwanda, at the College of Science Technology, in a center called African Center of Excellence in IoT. I'm going to present by following these different points: introduction, existing systems, problem statement, system architecture, results, conclusion, at the end, references. As a short introduction, landslide have been challenging the world and my country due to the loss that they cause to the lives, the natural environment, and infrastructure. There are different strategies which has been put in place for mitigating or reducing risk caused by this natural threat. Among those strategies, they include digital technologies for risk reduction. They comprise digital mapping, landslide prediction, and the early warning system. Nowadays, one of the digital technologies used is the IoT, which has the capability for quick data collection from remote site transmission, analysis, and alert to the people under risk. There are various existing systems that can be categorized in either regional or local. For example, at regional scale, there's a Hong Kong landslide warning system, Lewis for Java and Indonesia. At the local scale, for example, there is a Acnes rock slope in Norway. Regional Lewis utilize weather stations, radars, and other technology which can be expensive to some governments. The accuracy and the reliability of Lewis is a challenge because of the coverage area due to the poor spatial distribution of rain gauge. Local Lewis can overcome different challenges of regional Lewis, and the reliability of Lewis depend on good threshold. Most of Lewis or landslide early warning system use rainfall data as the main parameter to predict or for landslide early warning systems. The local Lewis require site-specific rainfall data. For that, we propose a site-specific so that we can have more data about the specific site. Soil moisture is one of the most useful parameter for landslide early warning systems. To overcome the problem of poor distribution of rain gauge, as mentioned before, an experimental study was conducted. We proposed an experimental study and we conducted it to determine the threshold for both rainfall amount and the soil moisture so that they can be implemented in the proposed system. Different sites have been chosen because this parameter can be different and the threshold can differ according to the characteristics of at a specific site. So we included like a slope, inclination, soil types, and land cover as a parameters to be considered in identifying the threshold for the two parameters. We used a rainfall simulator to provoke slope failure, and in this experimental study, we use soil moisture to capture the soil moisture content and rain gauge to measure the rainfall amount. The proposed system has 3 layers. The first layer consists of sensors, that is a perception layer, and the network layer consists of a gateway and the other interconnecting devices. And here we use the cellular network, and the application layer for data acquisition, storage, analysis, and visualization. The sensor node is made of Arduino as a microcontroller, and is connected with the soil moisture sensors. We use 3 sensors to be placed in different level underground. For example, sensor 1 was placed in the 20 centimeter top, and the middle sensor 2, was placed in between 50 and 70 centimeters, and the sensor 3 was in deep around 100 and 120 centimeters. We also connected GSM module for wireless transmission of data. As said before, we we performed an experimental study in order to identify the threshold for rainfall and soil moisture, so that they can be implemented in the proposed system. So the figure indicates the correlation between soil moisture and the rainfall for 3 sensors. And the site on which, for example, these data were captured was characterized by silt sand as a soil type, slope inclination of 26%, and the land on that side was covered by crops. Also, figure B indicates that that site was having a soil of lean clay, and our slope was 29%, while the land was covered by crops. And then we conducted this experimental study at 11 sites, and among these 11 sites, we provoked a landslide, and out of 11, 6 of them could indicate the sign of slope failure. Now,
dear presenter, sorry to interrupt you, but you have last 1 minute.
Thank you. I will be finished. The last, also this figure indicates the slope failure at a different site according to the different geofactors like land cover, soil type, and the total rainfall amount. As a conclusion, we tested the system at 7 sites, and out of 7 sites, the 5 were successful, and these are the values that the maximum values for soil moisture for the 3 sensors, and this figure indicates the data captured and visualized on the system dashboard. In our future work, we propose to integrate rainfall data and machine learning into system. These are some of the references that we used. I thank you for your attention.
Thank you, Mr. Martin. So we can proceed to the next one.
Okay, so our next presenter is Pallavi Arora, and her paper title is Security in Industrial Control System Using Machine Learning Algorithms in Overview.
Thank you, sir. Good afternoon, everyone. I'm Pallavi Arora, and my topic is Security in Industrial Control Systems Using Machine Learning Algorithms and Overview. And here is the contents of the presentation: introduction, attacks on IoT, machine learning and ICS security, intrusion detection system, literature review, and then in the last, references. So in the introduction, we will talk about what are the ICS systems. Basically, ICS is a general term comprising of process control system, DCS, and SCADA systems. They basically operate power generators, petrochemical operations, dams, and chemical industries. The main focus is reliability and safety. Then the components of the ICS, which we have talked earlier: SCADA, DCS, and PLC. What is the SCADA? It is a type of software application program that basically controls industrial processes and collects the data from remote locations in the real time and takes supervisory decisions to adjust the controls. Then the name suggests distributed control system. In the subsystems are geographically distributed and basically functionally integrated. And then PLC, it is a digital computer used to automate industrial electromechanical processes. This is the architecture of ICS, in which the data is collected from the feed level, that is level 0, then passed on to the level 1, that is control network, and analyzed with the help of SCADA system and shown to the user in the level 3. That can be corporate network or anything, application user. Field devices collect the data, industrial data from remote sites, and then data is sent to control center by a wired or wireless link, and then data is assessed by the clients with the help of control server. Then cybersecurity in ICS. It is a practice which intends to protect the computers, networks from unintended or unauthorized access. In ICS, first and foremost consideration is safety, but after that, availability, that the system is always up and running. Then comes integrity, which makes sure that what is showing on control room screen also matches with the reality. And then in the last, confidentiality comes in play. Here, the data does not require the same level of security as in IT networks. So attacks on IIoT. Industrial IoT may be targeted with many attacks. Basically, a cyber attack is an intentional endeavor by some individual to penetrate the data arrangement of another individual. This diagram depicts the types of several cyber attacks. It can be malware, phishing, man-in-the-middle attack, DOS, DDoS, SQL injection, and cross-site scripting. So these attacks are discussed. Malware, basically, it's when a user clicks on some malicious link or email attachment, it installs a harmful software. And then the critical network elements is disabled, that is ransomware, or some potential dangerous software is installed. Then comes a structured query language. It happens when an attacker injects malicious code into a server that uses SQL and forcing the server to disclose the details which it would not usually reveal. Next attack is cross-site scripting. The injection of malicious code into some compromised web application is known as cross-site scripting. Then comes phishing. It is a method of transmitting forged emails to someone and it shows that it is coming from some trustworthy source. Basically, the main aim is to steal the information such as credit card numbers, passwords, to infect the computer with malware. Then comes a man-in-the-middle attack. It is basically eavesdropping attack when an attacker inserts himself into a two-party conversation. It will then filter and steal the data after interrupting the traffic. Then the next attack comes denial of service attack. In denial of service attack, basically it stops the proper functioning of the system. Traffic jamming is the best example of DOS attack, in which high volume of traffic are sent to the network endpoint. It can be to overwhelm the endpoint by either sending transmissions faster than they can be processed, or by sending packets crafted to cause software errors and let the system crash. Then why machine learning in ICS security? With the arrival of Internet of Things, it is expected that thousands of devices will be connected to the internet in future, and there will be great trouble if we will not protect these networks. So it is impossible to manually track all the data. So we will use machine learning to analyze the data and identify unusual behavior. And machine learning methods can also be applied to historical data to show how an attack looks like and how it can be prevented in future. Then, what is an intrusion detection system? It is a framework for keeping track of and checking activities in a computer network environment to detect the possible threats and raise an alarm. It is basically a software program to detect such intrusions. There can be categories of the IDS based on different sources like detection, data source, and mechanism. On the basis of detection, anomaly detection, signature detection, and hybrid. If we consider on the basis of data source, it can be NIDS and HIDS. Then comes for the detection of known threats, signature detection is used, and the normal behavior is monitored using anomaly-based detection, and it distinguishes between irregular network and device behavior. And in the last, we can also use the hybrid-based approach for combining both the misuse-based and the anomaly-based. And then on the basis of next categorization, that is on the basis of data source, NIDS versus HIDS. NIDS basically tracks traffic from all the devices entering and exiting the network at the network level. It analyzes the traffic in order to spot trends and suspicious activities. And HIDS tracks device data and looks for malicious behavior on a single host. Basically, internal changes can be detected by a host-based intrusion detection system, while a network-based IDS can detect malicious packet when they reach your network. And then comes the literature review. In our previous published work, we have analyzed different machine learning algorithms such as random forest, SVM, decision tree, artificial neural networks, KNN, naive Bayes, and their efficiency matrix are recorded for detection against ICS. And the results demonstrate excellent machine learning algorithm in detecting attacks as well as low erroneous alert rate, implying that it actually identifies the normal traffic and distinguishes well with the anomalous traffic. Then in the next paper, IoT is a key part of building manufacturing facilities. So different sensors and electronic controls are also providing interconnection with the universal networking and data capabilities. So their safety concerns have now been prioritized by IoT suppliers. In the 16 number paper, the different safety problems of IoT are divided.
Sorry to interrupt you, but you have last 2 minutes. Please conclude it.
Okay, sure. The different safety features are divided into two parts. The one which is applied to IoT, and then second, which are unique to manufacturing structure. And then authors in one examining the transition from the ICS from being a standalone platform to a cloud-based system. And in the next paper, the rapid growth of internet interdependencies has resulted in increased cyber attacks, which may have catastrophic repercussions. So we should plan accordingly, and malware is the most common tool. So we need to work on the development of more innovative and effective malware defense mechanisms. And in this table, basically we have enlisted the different data sets, learning models, and attack types in the research methods used by various authors over the years, and the different metrics used by them for evaluation. Thank you. That's all from my side.
Thank you, Pallavi.
Thank you, Pallavi. Yeah.
Thank you so much, sir.
Sir, if you have any question for Pallavi.
No, I don't have any right now. Do we have any other? Because I think we have already this.
No, sir, we are just closing the session. Just 2 minutes.
So thank you, everyone. This is the end of the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was more informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team ICT4SD. I also thank our session chair, Faraz Kothari. Thank you, sir, for chairing the session. A token of appreciation to the chair on behalf of team ICT4SD. Thank you, sir. Thank you for your valuable presence.
Thank you very much.
Yeah. Dear all, I kindly request all you all to on the camera for a quick snapshot of the virtual conference, if you can do so, please. Just a minute. Yeah. Thank you. Thank you so much. Thank you, everyone. See you. Take care all. Bye-bye.
Thank you. Thank you very much. Bye-bye. Take care.